The next question that I received this question from a student, is that I know I am off weeks, but I wanted to review three phase. I need help understanding why the phase sequence in study guide has VCA lead VAB, while the OD lecture has VCA lag VBC. Okay. You can find a little bit of a discrepancy over here. I think the student meant to say VCA is lagging VAB in one case, and VCA is leading VAB in another case. So I'm incorrectly getting VCA is equal to 208 angle minus 180 in lieu of 208 180 for my study guide answer. Okay. So he's basically including a problem statement, included a screenshot of a problem statement. This is 4.1a from my study guide. And over here, just to laser focus on what the issue is like, okay, this is my VAB. All right. And VAB is 208 60 degrees. Now he's comparing VAB and VCA, correct? So VAB and VCA, he's looking at it and he's saying that, okay, if your VAB is equal to 208 60 degrees VRMS and your VCA is equal to 208 180 degrees VRMS. So if you look at it like this, let me actually draw a phasor diagram as well very quickly. Correct? So these are 180 degree roughly separated. So our VAB, if I were to plot my VAB, so 60 degrees is going to be something like this, right? 180 degree is going to be like this, okay? And then there's going to be 120 degree for the VBC. So this is minus 60, okay? This is plus 60, and this is 180. All right, guys. Now, how can we, first of all, is this correct? Do you see any issues with this? Just focus on the phase angles. If the phase angle for VAB is 60 degrees, for a balanced system, do we expect the VCA to be 180 degrees? Correct? Yes, we do. Right? We do. So there's nothing wrong with this. This guy is 120 degree phase shift. Correct? Okay. And this also goes back to another concept that we have explored in a lot of detail in the course, and that is, yes, positive sequence and the negative sequence, ABC and ACB configuration, right? In some parts of the US, okay, notably in Texas, if I'm not mistaken, which sequence do we have? Do we have ABC or ACB? In Texas, I'm pretty confident we have ACB. Okay. In the Northeast, what do we have? ABC or ACB? It is ABC. Okay. All right. So let's park this one here for a second. Now, it's a very fundamental concept. And for some of you, it may be very obvious. And you'd be like, Wasim, just move on to the next question. But the important thing is to be able to understand and explain the fundamental concepts using first principles. Okay, because if you can repeatedly do that, you don't have anything to worry about on the exam. I can guarantee you. But if you're unable to collect your thoughts and approach a question that is just randomly asked in a methodical manner, you are going to fall short on at least a handful of problems. Okay, so please bear with me and work through this in a systematic manner. And hopefully this will help you deal with problems similar or more difficult or more easier than these type of open-ended questions. Okay. All right. Now, this is a screenshot that the student took from the on-demand course. This also includes a problem statement. Now, let us zero in. So VAB, so his issue is with VAB and VCA. I'm going to write the VAB and VCA over here. VAB is equal to 173.2 phase angle of 50 degrees VRMS, okay? Unless mentioned otherwise, we always treat the voltages as RMS. And obviously when it is in phasor format, You don't even need to be told that the magnitude that you're seeing next to the phase angle is a RMS value. Okay. And when I look at my VCA is equal to 173.2. The magnitudes are the same. Okay, so that's the first check for a balanced system. And when I look at my phase angle, guys, it is minus 190. So if I revisit the question that the student is asking, in one case, he's saying that VCA is leading VAB. Okay, true. 180 is greater than 60. So you can say it's leading, although, depending on how you look at it, strictly speaking, it can be incorrect, right? And then we have BCA, which is lagging VBC. Correct, guys? And the way that he's looking at it is like, okay, compare the 50-degree angle with the minus 190-degree angle. So one is a positive angle, the other one is 190. So what is going on here? Are you guys following the train of thought? So that's why I tell my students that approaching the problems are actually, as the way you approach a problem sometimes can be problematic itself, right? So that's why take a deep breath and put some thought into how you're going to even start a question or interpret a question. I think the way that the student framed the question, okay, with leading and lagging and all of that business, threw him off balance and on a wrong trajectory. Now, I hope that your thought process is much more clearer than this, but to be quite honest, um, this can happen to anyone, especially under time constraint and stress, exam pressure. Okay. Now, when we break this down very quickly in the next step, I'll convince you that both are correct and both are actually the same. And the link is what? What is the link, guys? Can somebody help me? 360. How come 360? 360. Why is 360 the link? Because when I look at minus 190 degrees and add 360 degrees to it, what do I get? 360 minus 190 is equal to, and you got to remember that these are two different scenarios, so they're not the same problem. So the answers we are getting are not going to be the same. So if I quickly do 360 minus 190, I get 170. So if I now present the value of VCA to my student as 173.2 and 170, I think he'll be happier because now he's seeing the consistency, right? But another underlying issue is that you are approaching a problem with a very, how should I call it, inflexible, right? With a very, like a preset mindset, okay? That you're trying to memorize that, okay, always, 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 VCA is going to lead VAB, right? So exactly, don't lock yourself in a box. Just hang on to the first principles and the basics, and everything will make sense. So in a 4-quadrant system, adding or subtracting 360 degrees does not make any difference whatsoever. Does it make sense, guys? All right. Okay. And you can see that if you start going down this route for a relatively simple, straightforward problem like this, you have put yourself in a spin, right? You are unnecessarily making it difficult. I'm going to use this opportunity very quickly to revisit ABC sequence, VA, VB, VC. What happens is that in a positive sequence, our phase A is followed by phase B, which is followed by phase C. So strictly speaking, your phase A is leading phase B by 120 and phase B is leading phase C by 120. So that's why I mentioned earlier that when the student said that, okay, VCA is leading VAB, that's not 100% correct. Correct? Right? And the reason is that when we extract the line voltages out of them, this is line voltage VA minus VB. Then we have the line voltage VB minus VC. And the last but not the least, because this keeps on repeating, right? VA, VB, VC, VA, VB, VC, VA, VB, VC. This is VCA. So, as I explained in the course, VA corresponds to VB, VAB. VBC corresponds to VB. And VCA corresponds to VC. Does it make sense, guys? Okay. And that's the reason why in a positive sequence, you can only have VAB, VBC, and VCA. And conversely, as we discussed, when we have a VA, VC, and VB sequence, okay, what happens over here? I do a VA minus VC, so I have a VAC. I have a VC minus VB, which gives me VCB, and I have a VB minus VA, which is giving me VBA. So if you see a VAC, that tells you that you are dealing with a negative sequence. And VAC corresponds to phase A of the negative sequence. VCB corresponds to phase C of the negative sequence. And VBA corresponds to the phase A of the negative sequence. In a negative sequence, you cannot have a VAB. And in a positive sequence, you cannot have a VBA. Okay, these are the fine concepts that we have discussed and understood in the program, in the course. And for all we know, for all we care, you may never be tested on this. But when you have this level 3 understanding, no matter what they throw at you, you're going to be able to field it and, convert that into a point on the exam. And that's our goal. We are not trying to hang on to bits and pieces of knowledge and attempting to memorize different frameworks. We are working from first principles with confidence so that anything and everything can be dealt with confidently on the exam. And if you want to learn more about preparation of FE Electrical and Computer exam and the P-Power exam, then check out these playlists over here. Thanks for watching, and I'll see you soon in the next video.